Yo, 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 word up here, the Marky Canoe here. I've been in awesome chemistry educational videos as moles part 2. They're not holes in moles or moles in holes. And Dr. Seuss in chemistry. Who would have thought? Okay, so we're looking here at stoichiometry, and now we're going to look at another thing that is pretty common in stoichiometry, where if you're looking at the moles, which remember, it's a number. It's like the chemist's dozen, that's what I call it. Okay, the moles. The moles is something and how we can change that to grams. Okay, in the last video, I showed you going from grams into moles. Now we're doing the opposite. We're going to do moles into grams. Okay, so this is what we have right here. Here's an example. Okay, 3.5 moles of water gets us how many grams of water? Now, the big secret for this formula, if we're going to go from moles to grams, we have to multiply in order to do that. Okay, so what are we multiplying? Well, we got it. We got the 3.5 moles, but what are we multiplying? Well, we're going to have to multiply it by the how many grams there are in a mole of water, okay? Also known as the molar weight, molecular weight, formula mass, molecular mass. There are all these different names, but they all mean the same thing. Grams per mole. And wait, oh my gosh. Wait, Canoe, I forgot. How do I do grams per mole? Not a problem. Here's a quick primer. With a calculator and the periodic table, you'll get there in no time at all. All right, well, let's take a look. For water, this is fairly simple. We got 2 hydrogens and 1 oxygen. So for hydrogen here, again, if you didn't see the other video, I'll just quickly go over this with you. When you look at the periodic table, like this, let's look at hydrogen. You got a 1 up there, which is the atomic number. That tells us how many protons there are in a nucleus of an atom. Yay! Is that going to help us for stoichiometry? No, it's not. Well, what about the element abbreviation? H. Well, that's great for knowing about the formula, but does it help us calculate stoichiometry? No. Well, what about the name? Hydrogen. Well, what about my name, Grandmaster C? Does that change anything? Does that help you calculate stoichiometry problems? No, it just doesn't. So, here we go. Our last thing is that 1.01. There's 2 things involved with that 1.01. One, it tells us how much does 1 atom of hydrogen weigh in atomic mass units. Huh? 99.999% of the public will never use it. They won't. However, fine, discriminating chemistry students like yourselves get to use this for another purpose, because 1.01 also tells us how many grams does 1 mole of hydrogen atoms weigh. So it's 1.01, which means in the palm of my hand, if I have this mole, this giant number of hydrogen atoms, it's going to weigh 1 gram. Ooh, yeah. Imagine that. You'd say, that's weak sauce. You're right. But you see, when you start coming down here, when you start looking at things like gold or mercury or lead, you're going to find it, yeah, it does get a little heavy. Let's get back here. So hydrogen's 1.01. Oxygen is 16.00. Let's go back so we know H2O, I'm going to break it up. We got 2 hydrogens, 1 oxygen, okay, 1.01, 1.01, 16.00, and we have 18.02 grams per mole. Now, where did I get those numbers? The periodic table that looks just like this. You have oxygen here, hydrogen here. That's how it works out. Okay, now all these are grams per mole. So it's going to look like that. So we're okay. So now we're going to multiply. We're going to multiply our 3.5 moles moles multiplied by 18.02 grams per mole. And let's take a quick look and see how it comes out. Okay, so 3.5 times 18.02, and we have, woo, yeah, okay. So we have ourselves, ladies and gentlemen, 63.07 grams of water. Woo. Yeah, that's a lot of work there for a day. I think I'll take a break. No, not really. All right, let's take a look at another one. So here's one, 15.2 moles of CO2 equals how many grams of CO2 do we have? Okay, well, again, we have our formula. If we go from moles to grams, we're going to multiply. Notice how I write the formula. Do you have to write the formula on your paper? No, but if it helps you, then do it. Come on, you know you want to. Just write the formula and you're good. Okay, so I got it. I got 15.2 moles. And, oh, what do I do next? That's where we have to find out the grams per mole. Okay, so here's grams to 1 mole of CO2. Now, check this out. Notice I did this a little bit differently. I put grams over moles like I did. I didn't make it that obvious in the first one, but you kind of notice something? The moles cancel out. They cancel each other out. Like two biorhythms opposing each other. They cancel each other out. Yep. So, now we got to figure out how many grams there are in a single mole of carbon dioxide. Well, let's go, and we know that we have carbon and we have 2 oxygens. So I know I have 1 carbon. Each carbon is going to weigh, let me check my periodic table, 12.01, got that. So it's going to be 12.01. That's going to equal 12.01 grams. Okay, and then I've got how many oxygens? 2 oxygens, so 2 times O, and each O is going to be, check it, 16 grams. All right, so I've got 16 grams, and that's going to equal 32.00 grams, and again, per mole, and then we just add them up, and we have 44.01 grams per mole. Now, that's important. This is the how many grams there are in a mole of carbon dioxide, which we need. Because if we got 15.2 moles and we've got this many grams, so now we got to go ahead and let's just plug in 44.01. Okay? Another way to look at, well, no, I'm not going to do analogies here, not today. So I got 15.2 times 44.01 equals, and I got 668.95 grams. So that's how many grams total I have of this CO2. Al Gore would be in a tizzy on this one. Science political joke, for those of you who are wondering. Okay. Any questions? Wait, it's a video. Now keep in mind, if you don't totally understand this, A, I'm going to do one more example, and B, you can always go back, because I try to point out the details of every single step. And sometimes you may have to see it over and over again, and that's okay. That's perfectly okay. Alrighty, let's take a look at this one. Oh man, 415 moles of sulfuric acid. Power. Yeah. Okay. Well, I'll go ahead again. Moles to grams, we're going to multiply. We just are. So, okay. So I know I'm going to have to figure out, wait, I got the moles part. I got 415 moles. Yep. By golly, I got that, but oh, what do I have to multiply? Again, it is the grams per mole, the molar mass, the molecular weight, the formula mass. The names are interchangeable, but the bottom line is grams per mole. And you get it by using the periodic table, and you add up all the parts. Yeah, that's how it works. Add up the parts! Because if you don't add up the parts, you're not going to get the grams per mole. You're not. Okay, let's check this out. So I got H2SO4, so I know I got two H's. Oops, here, let me erase this. Ooh. I have two H's, I have one S, and then I have 4 oxygens. Okay, so I need to write up how many each one is. So for the H, I go back to my periodic table, I find that 1.01, okay, so I got 1.01, and that's going to get me 2.02, and again it's grams per mole, okay, and then for our S, let's find S, here it is, sulfur, 32.07, let's go, let's put that in, 32.07 is equal to 32.07 grams per mole. That's for the sulfur, the stinky stuff. Oxygen, here we are, it's right above sulfur. It's 16 even. Oh, that makes it so much nicer. So if each oxygen is 16, that's going to get us 64.00 grams per mole. So now we've put in our numbers, H2S, 4 and O4. We've figured out these numbers, again, using the periodic table, okay? And then we're just going to go ahead and add those up. So we go for 9, 0, 2 and 2 is 4, 4 and 4 is 8, 3 and 6 is 9, so that's going to be 98.09 grams per mole of H2SO4. That's our key, because now we can go back up and we can now plug it in, 98.09 grams per mole. Oh man, this is going to be huge. It's going to be as huge as the last release of my album. Woo, yeah. Okay. 415 times 98.09. And here we go for the drum roll, please. We have, oh my gosh, 40,707.35 grams, or about 40, not quite 40 kilograms. Oh my gosh, yeah. So, this is it. This is the other tool, ladies and gentlemen. As we go from moles to grams, in this one you're going to multiply. Unlike the others where you say grams to moles you divide, moles to grams are going to multiply. So typically you should be seeing larger numbers like this one. We did 3 examples, okay, went from two things that we were quite familiar with and we kind of need, and here we got ourselves a bigger molecule to go ahead and work with. Okay, that's it for this video, and I hope that will answer all your questions. All right, till the next time.